Okay, question number 9. This is a free response question, and we'll need to use our calculator. Mr. Weissert's 26 math students, I made these up, by the way, had the following results on their first test. And you can see the data. Construct a box plot of the data. Be sure to include the values of the 5-number summary. Well, I put it in here. You get stat, edit, enter your data in. Pause the video if you want to do that. Try it on your own. Then you go to second y equals. Press enter a couple times. Go down to here for that first box plot. Click enter again. Then do a zoom 9, zoom stat. And there's your box plot. Oh, you want to get the values. All right, let's trace it. You can go through and get all those values. So you have your min, your Q1, your median, your Q3, and your max. And your calculator is saying none of those are outliers. We'll back that up with some math a little bit later. So it says construct a box plot of the data. Well, it's a little bit skewed to the left. So am I looking for perfection? No. But what do we want to have on a graph? General shape is a good thing. Right values, of course. Q1 being 68, 79. Q3, 89 and 99. Those 5 numbers are your 5-number summary. What is this graph? It is test scores. In fact, it's Mr. Weissert's first period test scores. Not his, he didn't take the test, but his students. But you know what I mean. Label your graph. That's all you need. Now, of course, many of you drew a number scale, which will get you a little bit more accurate picture as a result, but that's really all it comes down to. All right, so now we got a question where we want to describe the data, the distribution of the data. And this is actually in a free response question, this would be the majority of your points. So we want to address the SOC-V, shape, outlier, center, and variability. Here is a sample write-up that I made here, and I'll kind of annotate over a little bit. The shape of the distribution of Mr. Weissert's student test scores is skewed left. The scores range from as low as 40 to as high as 99. So we got the shape, right? Skewed left is going to be, that's your SOC-V, your S part. The scores range from as low as 40 to as high as 99. That's your variability. Or you could also include the middle 50% between 68 and 89. Your IQR is also your variability. So you didn't have to list both of those. I just did so you can kind of see the difference. And it's centered around 79. So now we have our center. And there do not appear to be any outliers in the data. So we've addressed the outliers. Now, if there are no outliers in the data and you didn't mention those, you're off the hook, because technically, if you don't bring them up, you're telling the reader that you don't believe there are any. But I always like to just say, hey, doesn't seem to be any outliers, so that we're clear we've addressed all 4 points. What are the mean and standard deviation of the data? You don't need to do any work for this. You got your data in here. Go to calc, 1 variable stats, down to calculate. Your mean is that X with the bar. Standard deviation is the SX. So 15.8, 76.9. And, you know, we can include context, you know, percent. Oh, I'm going to go back to this one real quick here. Always include context. Notice that I said the shape of the distribution of Mr. Weissert's student test scores. I didn't just say the shape is skewed left. The numbers are from 40 to 99. The middle 50% is from 60 to 89, centered around 79. There don't appear any outliers. I said the shape of the distribution of Mr. Weissert's student test scores. Context is so important in statistics because you got to know what you're talking about. You can't just throw numbers out there and make assume people make sense. So always throw context in there. Back to this. Notation. This is your notation, right? That's all there is to it. All right, the last part here, it says for the data, a test score below what number would be considered an outlier? Show your work. There's two ways you can mathematically calculate that. One is anything lower than Q1 minus 1.5 IQR. So if you know the IQR, that's going to be, I believe it was, I'll go back here real quick. 89 minus 68. So 89 minus 68, and it's going to be 21. So lower than 68 minus 1.5 times 21. And that ends up being 36.5. Double check that math. So anything lower than a 36.5%. Now, chances are, you know, we're in whole percents here, so you could set 36 or lower, and that's fine. But that would be considered an outlier. You could also do the mean minus 2 standard deviations, and our mean minus 2 standard deviations, 76.9 minus twice, what is that? 15.8. And that could get you a rough estimate there. And those numbers will be different, but as long as your method is consistent, you know, it doesn't really matter which one you use, in my opinion, unless a question specifically tells you to use a certain one. Any one is fine. So I'm saying anything lower than a 45.3 there. And so as you can see here, you have a 40. So technically, by that definition, 40 is an outlier. So if you go back to the description, you could say, well, 40 might be considered an outlier based on that rule, and you'd be okay. But yeah, that's the idea. Anything less than 36.5 or 45.3. That is problem number 9. That was the biggest chunk of your overall quiz.